Perfect. So let's start. So the first thing I want to ask you is to briefly describe what your paper is about.
Yeah, so a paper came to our attention in which the authors had found that, contrary to what we would have expected, that students in their study had showed a preference for having their mathematics questions delivered without an embedded engineering context. We'd always assumed that this would be a motivating thing to see, to help students see where their mathematics is going to be used. We don't want to be met with the question, when am I ever going to use this in engineering? We want to preempt that.
Exactly.
Uh, so that was a surprising result in that other study. So we wanted to know whether those results applied to our context with our students studying engineering mathematics in their first year of an undergraduate at our university. Um, and one of the things we noticed about the study that had motivated this investigation of our own was that there was there was not an exact equivalence between the question with and without context. There seemed to be a requirement to do more in one than in the other. So we said, well, not only do we want to know if their results apply in our context, but also we want to investigate this using questions that we thought are a bit more equivalent. So um, we essentially gave our students questions that were they get called dressed up problems. There's no modeling
Yes.
requirement.
Mhm. Yeah.
And so yeah, we wanted to see what students' perspectives were in terms of their preferences on these different things.
Yeah. Very good. So is the old question about context or no context?
Yeah, precisely. Yeah.
Yeah. So which were the findings or outcomes of this research?
Well, we asked a number of questions. First, we wanted to know, what's the preference? Are engineering students preferring with or without context? Is there any alignment between what their preference is and they what they find more difficult? Um, is there any alignment between what they prefer and how they go about problem solving? And we also wanted to know whether it's particularly important if the embedded context is directly relevant to their flavor of engineering, so a mechanical engineer is getting an electrical engineering question, that
Yeah.
sort of thing.
Mhm.
Um, so what we found was that there was a preference for problems with an embedded engineering context, but it wasn't a strong preference. It was like 58%
Okay.
were keen on the engineering context, and not the sort of dramatic thing that I perhaps would have initially expected. And it certainly meant the motivation for the study was sound. Um, what we found was that despite that fairly even split on preference, most of the students, it was almost 80% of the students in the study, said that they were finding that the in context problems, bearing in mind these are little more than dressed up problems, almost 80% of students found those ones, the with context problems, more difficult. So there's no alignment really between who finds what more difficult, and it's just a matter of saying, I find this easier, therefore uh, I prefer, and I find this easier, therefore I prefer. We're finding that there's quite a few students who prefer the engineering context despite finding it more difficult, um, which was an interesting outcome. Their motivation for seeing potential areas for application is outweighing their desire just for an easy ride. And as to the last one, whether there is a strong preference for getting questions in your own context, there was. So we concluded that if if students are getting some context in their mathematics, there is value to aligning it with a specific branch of engineering, rather than, you're engaged in engineering, therefore you should be, being exposed to all of these different things. They seem to be more motivated or keener to get those specific ones.
Yeah, students actually recognizing that applied problems or contextual problems are relevant and significant, interesting and useful, but they still find the non-contextual problems straightforward and they prefer it.
Yeah, so that was what was interesting about, I suppose, the interplay of the first two research questions was that, while it was an even split on preference, it wasn't an even split on which they found more difficult. Because the questions branched depending on what their response was, we were able to say, right, given you've answered this to this, what do you find more difficult? And they weren't just, taking the path of least resistance in all cases and saying, well, it's easier, therefore I prefer it. So that was encouraging.
So finally, what lessons can we derive from these results for the teaching and learning of mathematics?
Yeah, so I mean, given the even split, a mixture of approaches is certainly going to be valuable. It means you're going to be able to, satisfy everyone. While it wasn't necessarily part of our investigation, it is acknowledged that, we've got colleagues in engineering that are going to hope that these links between mathematics and engineering are being reinforced elsewhere, even though it's not necessarily something that the students are always craving. Given that students find it more, well, they report finding the in-context problems more difficult. As you say, it's not especially surprising. We recommend, careful thought when including context and non-context in assessments. And maybe if it is going to be in an assessment, try to provide more preparation for this sort of thing through, any formative feedback mechanisms, weekly worksheets, and these sorts of things. Given the students' strong preference for, if you're going to give me context, can you give me electrical engineering? Because I'm an electrical engineer. Do make attempts to align problems to particular disciplines wherever possible. This could be, these things all take time, but you could have a suite of problems that are, essentially the same problem, but maybe from a student's perspective, they're ostensibly different because the window dressing is a little different, and you don't really have to genuinely write separate questions. You can just embed it in a slightly different context and guide students to different problems. It's something I certainly do in my lectures. I'll jump to the example that's relevant for the electrical engineers and one for the mechanicals.
Okay, well, that's very interesting. And we really encourage our readers to go and read your full paper to get all the details. Okay.
All right. Thank you.